We're given this series. Let's just take a little look at it. Every term we're timesing by k. So this is looks like it's gonna be a geometric series. And to go from 4 to 8 over 7, we're timesing by 2 over 7. Then we're timesing the top by 2 and the bottom by 7. So actually it's going to be 2/7 k every time. And it's infinite series. In fact, we can see here's the nth term. So a is equal to 4 and r is equal to 2/7 k. So the summation, which is a over 1 minus r, is going to equal 4 over 1 minus 2/7 k. Now, k is an integer between -5 and 5. So actually, that's 11 different values because it can have 0 as well as 1 to 5 and -1 to -5. And we're interested in whether the summation becomes a finite number greater than 3. And we want to know basically how many of the numbers give that, and then we can work out the probability if we picked one at random. So one way to do this question, actually, this is how I did it, is you could just now sub in different values of k and get a feel for it, but we're going to do even better than that. We're going to solve 4 over 1 minus 2/7 k greater than 3. This route is a little bit trickier because this inequality you can't just times through by 1 minus 2/7 k, because if it's negative, the sign would swap around. So let's find out when it crosses over from being negative to positive. When this is equal to 0, then 2/7 k would equal 1, so k would equal 7 over 2. So that means we require that k is less than 7 over 2 so that the denominator remains positive. If I start writing some of the numbers out, -5 and 1, 2, 3. Well, I can already rule out 5 and 4. They would lead to the denominator being negative. Okay, so given that k is less than 7 over 2 and the denominator is positive, we can now times through by it. So 4 is greater than 3 times 1 minus 2/7 k. Becomes 3 minus 6/7 k. So 6/7 k is going to be greater than -1, and k is going to be greater than -7 over 6. Okay, that is a requirement for the summation to be greater than 3. So now I can rule out -5, -4, -3, and -2. -1, or -1 is what? No, -1's okay because -1 is greater than -7/6. So that means we've got 11 possibilities, and these two and these three would lead to the summation being greater than 3. So our answer is going to be 5 out of the 11, which is option E. Like I said, if that felt a little bit technical, then it's arguably quicker, I think, to just sub in some values for the summation. Like, it doesn't take long. You can sub in -5, for example, and quickly see that that one doesn't work, and sub in 0 and see that you get 4, it does work, etc. But this is how you can do it algebraically.